Hello and welcome to the solution to my drawing those little figures problem. So which one are possible, which ones are not, and why? Well, actually, to understand what happens, it's called Euler's theorem. Euler was a great mathematician, but we're not going to go through very difficult math. We are going to use this. This is just a piece of string, plastic string, and this will illustrate how it works. So on a string, you have two possibilities. Either you have two ends, either they're melted together, and you don't have any end, and you have a loop. And this is actually everything we need to know to understand how it works. Another thing, you can also cross a string like this. And of course, because you cross like this, you go in and you go out. So if you take your normal string, if you go in and out, you will have 1, 2, 3, 4. One in, one out, one in, and one out. The only way you cannot, you can also do it twice, and which will on this knot add up only 2 strands. So what happens on any knot, you will have always an even number of strands, except in one case, if you're actually at the end of the string and you don't go out. So if we take back those shapes, actually a line with a pen is exactly like a string. So let's check those knots and let's see. This one has 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Those are even. No, those are odd. This one is even. Those have an odd number of strands, which means that we have 1, 2, 3, 4, a rope, a string with 4 ends. Sounds weird, eh? Which means that you can do that only with 2 strings, not 1. In another word, you can't do that with only 1 line. You need 2 lines. So this one is not possible. Let's check this one. Maybe that way. Now we have 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So just normal string crosses here, except for those 2. So this means that we have 2 string ends, one here, one here. So that explains that this one is possible to do, but only if you start here, or you start here, here or here. And if you start anywhere else, this will not work. Let's check the next one. This one. How many do we have? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Actually, you can start anywhere because it's like a endless rope, which means a loop. So this is very easy. You start anywhere and you can do that one. That's a very easy one. And here, what do we have? 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. This one you can do it because you have 2 even strand numbered knot. But if you want to do it, you have to start here and finish here, or start here and finish here. This is the only way. If you start anywhere else, you won't be able to make it. And finally, the last one, where you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, etc. So here again you have 5, which is an odd number. An odd number. You have 4 unnumbered knots, and that's not good because that means that you have a string with 4 ends, and no, it doesn't compute with me. So that's a very simple way to explain and to understand Euler's theorem. And I hope you enjoyed it, and see you next time for next problem. Bye bye.